Hello, Grade 7. Today we will discuss the third and final method of thermal energy transfer radiation. At the end of this lesson, you will be able to identify and explain thermal energy transfer process of radiation. Before we talk about the details of radiation, I want you to imagine that you are at the beach on a hot summer day. You can feel the heat of the sun on your skin, and you feel the need to dip in the sea or pool to cool down. How does the heat reach our body from the sun even though it's 150 million kilometers away from the earth? And what's the method of thermal heat transfer? The heat that reaches us from the sun is carried by a type of radiation called infrared radiation or heat radiation. Unlike conduction and convection, this method of thermal transfer doesn't need the vibrations or movements of particles. Infrared radiation can travel in vacuum. It's actually the only method that can be transferred without the presence of particles. The sun is one example of heat transferred by infrared radiation. Any object that gets hot emits or gives out infrared radiation. The heat stored in the object will be emitted from the object itself if it was warmer than its surroundings. Remember that heat is transferred from warmer objects to cooler objects. Fire emits infrared radiation in all directions. This fireplace emits radiation from its sides. If you exercise or get sick and get warmer, your body will emit radiation as well. Nowadays, you hear a lot about thermodetectors that are used in airports to pick any passengers arriving with high fever in the efforts to control the coronavirus spread. These thermodetectors detect the infrared radiation level emitted by the passenger's skin and can show those with high fever. The surface of an object is really important when it comes to how infrared radiation is absorbed or emitted. For example, if you're wearing a black t-shirt on a hot day, infrared radiation in sunlight will be absorbed very well by the black t-shirt. You will warm up very quickly. But if you were wearing a white t-shirt, the t-shirt will reflect the radiation since white is a poor absorber of radiation and you will stay cool. Black matte surfaces are also very good emitters of infrared radiation once the object has become warm. On the other hand, light, shiny surfaces are poor absorbers and poor emitters of infrared radiation. They are also good reflectors. In hot countries, the houses are often painted white or light colors. This is to keep the houses cool, as white surfaces are poor absorbers and good reflectors of heat radiation. Another example is the teapot. The shiny light surface of the teapot is a poor emitter of infrared radiation, and so the teapot stays hot for longer. If we paint the teapot with black matte paint, the teapot will become a good emitter of heat and it will lose its heat faster. Sometimes we need objects to lose their heat and remain cool. For example, the cooling coils at the back of the fridge. These are usually painted black color with a matte finish, so the coils can emit infrared heat quickly to keep the fridge cool. If you look at this diagram, you will see a heated piece of metal which has a matte black surface and a shiny white surface. A thermometer is placed at the same distance from both surfaces. The thermometer next to the matte black surface shows a higher temperature than the one next to the white surface because the black surface emits radiation at a faster rate. Heat leaves the metal more quickly through the matte black surface than the shiny white surface. In conclusion, an object with a matte or dull surface will absorb and emit infrared radiation at a faster rate than an object with a shiny surface. An object with a dark surface will absorb and emit infrared radiation at a faster rate than an object with a light surface. Radiation is also reflected at the surface. Light, shiny surfaces are good reflectors of infrared radiation. Heat transfer happens through three main methods: conduction, when the particles come in touch with the heat source, either directly or through vibrations of particles; convection, the heating of fluid by forming a convection current, and this can be felt if you put your hand above the heat source; and radiation, which is infrared radiation emitted by hot objects in all directions and can be felt when you put your hand in front of the heat source. That's it for today. Thank you and have a wonderful day.